Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 29 of our complete DevOps course, and in this video we will take a look at Docker interview questions and answers. So the way I prepared this Docker interview questions and answer is to not just like any random questions and answers, but they are completely scenario based questions and answers. Practically this is how you will face the questions in the interviews, because people would not ask you to simply write one simple docker command or all. Basically it would be more of scenarios. So that's how I try to put the entire 12 questions that I have. And at the end of the video, just put in the comment section how many questions were you able to answer. Now this is not a competition, but just for understanding, okay, how our other subscribers or how our other viewers of our channel are able to answer the questions, and how are you able to answer the question. So it's just of how much practice you are doing, or how much are you taking away from the previous classes. From day 24 to day 28, we were only talking about containers and Docker. So to analyze what is your level of understanding or how much practice you have done to get some hands on Docker, this interview questions and answers would help you. So try to put that in the comment section. How many were you able to answer? Okay, so the first one that I have for today, what is Docker? Like you might feel, oh, okay, what easy question this is, but this question will help interviewers to understand. Like this can be, if you have to put it in another way, what is a container? So, right, either what is Docker or what is a container, because most of the times when interviewers ask you about Docker, they will not be keen to understand about the Docker platform, but they will try to understand your knowledge on containers and how you use Docker to work with the containers. So if somebody is asking you what is Docker, try to tell both of them. So Docker is basically a open source containerization platform, and why you're using this containerization platform is to build containers or to manage life cycle of the containers. That would be the very good way to put it. So Docker is a containerization platform, and it is used to manage the life cycle of containers. And in the interviews, basically talk about yourself. So you can say that, okay, I use Docker to basically build the Docker images, then write some Docker files, run some Docker containers, push them to registries. So explain what you have done with Docker. Okay, so this is a very easy question, but this will tell interviewers what is your level of understanding on Dockers and containers. Second question is how containers are different from virtual machines. So you might find question one and question two simple, but most of the times when you try to explain these things in interviews, what happens is you will fumble, or you will be with a blank mind. Oh, okay, now how do I explain these things? I know the concept of container, I know how they are different from virtual machines, but right now on top of my head, I don't have answer. It happens a lot of times, right? So practical theoretically you know what it is, but in terms of words or in English you might not be able to put that to the interviewer, and interviewer thinks that, oh, okay, this guy does not know Docker, or this guy does not know difference between containers and virtual machines. But on the other hand, you know it, but you are not able to answer. So that's why be prepared for these questions. So to answer how containers are different from virtual machines, if you go back to our video 25 and 26, where I completely explain you how containers are different from virtual machines, what is the difference, how much does a container image size be, and how much a virtual image size is. So I compared all of these things, but if I have to explain you, in short, containers are very lightweight in nature because they don't have complete operating system. So if you see the image also here, what you are doing is you are installing a Docker platform. On top of it, we are creating containers. Whereas once you install hypervisor, on top of which you have a virtual machine, but it has a complete guest operating system. And we all know operating systems are very heavy. And with having an operating system, the image size goes very high. And even you have some other complexities when you have the complete operating system. Whereas if you are talking about a container, it is basically a combination of your application dependencies and some system libraries. So never say that Docker container or containers do not have an operating system. There itself interviewer will lose you. You should say that, okay, so containers are very lightweight in nature because they don't have complete operating system, but they have very minimal system dependencies that are required to run your application. Probably you can also give an example here. You can say that, let's say I'm running a Java application. So what I would need is I need my application. I need some Java runtime dependency to run the Java application, and I just need some system libraries that are very required or that are like mandatory to run your application. So these are the only three things that you require, and containers are basically defined to have this very lightweight nature. Whereas in a contrary, if you're talking about a virtual machine, let's say you create an EC2 instance, you will have the application, you will install the Java, you will have the complete. Let's say you created a Amazon Linux or Ubuntu, so you'll have the complete Ubuntu operating system. You have the kernel and you have all the system libraries, right? Whereas here you only have the concept of shared libraries. That's the difference between containers and virtual machines. If you're not able to understand this one here, watch our day 25 where I explained you with practical example. I showed you what are the files and folders that are inside the containers and what are the files and folders that a complete operating system has, right? So if you are talking about a container, it has very minimal files and folders. Okay, now question 3, what is Docker lifecycle? So basically what interviewer tries to understand here is how much have you done with Docker. So there are different ways to manage lifecycle of containers. People use Podman, people use Builder for building the images. But if you are only focused on Docker, you must be capable of explaining the entire lifecycle. So by entire lifecycle, you mean you have right from the stage of writing a Docker file, building a Docker image, to creating a Docker container and pushing them to registry. So explain all of these things in the Docker lifecycle. So explain like, okay, so in my case, what I usually do is I start with writing a Docker file. Let's say a development team has approached, or let's say there is a requirement from the project to containerize an application. So I will initially start with writing a Docker file. In the Docker file, I will write the set of instructions that are required to run the application. And once I feel that the Docker file is complete, I will create an image out of it that you can create using the Docker CLI. What you can do is you can run Docker build, which will essentially convert your Docker file to Docker image. And after that, you can again use Docker run command to execute your container. So again, you will use Docker CLI to create a container. Finally, you can push your image to external registries like Docker Hub or Quay.io or anything like ECR or GCR or whatever you would like to, right? So this is the life cycle of Docker. And you can also pull the containers, push the containers. So explain all of those things. So for every question, I also try to explain the answers in these boxes, right? So this is very important. Like you might feel that, okay, I know the entire concept of Docker, but just be prepared for the interview so that you can put your whatever you have in your mind or whatever you have in your thought. If you want to put it in terms of words, you have to be slightly prepared, because all of a sudden if you directly jump onto an interview and you are not prepared with the theoretical answers, then interviewer will not know what is your practical exposure, or interviewers cannot believe you unless and until you put them in terms of your words. So even if you're watching the videos in Telugu, or even if you're watching the videos on any of your mother tongue language, try to come up with the answers in English. Like write these answers in English or practice these answers in English, so that for the interviewer your thoughts will be very clear. So that's why I try to put them in the check boxes as well. What are the different Docker components? So again, I explained this thing very well in the class 26, I guess, day 26, where if you're talking about the Docker components or you're talking about the Docker terminology, basically when you install Docker, you have various components. Like you have the client. So client is nothing but the Docker that you are trying to install, the Docker CLI. So using client, what you will do is when you install Docker, right, you install something called as a Docker daemon or Docker host. So if you are trying to install Docker on your laptop, what you would do is you would install Docker desktop for Windows or Docker desktop for Linux or Docker desktop for Mac. So what are the different components that come there are, firstly you have the Docker CLI, right? So once you have the Docker CLI, then when you install this Docker desktop, or even you try to install the Docker daemon, you get a Docker daemon which is responsible for executing your actions. Let's say if you look at this diagram here, there is a client. What is a client? Client is your Docker CLI command. Let's say as a user you have executed Docker build. What happens is this request is received by the Docker daemon, Okay, so who is Docker daemon? Docker daemon is the heart of Docker. If the daemon goes down, then nothing will work with respect to the Docker. Okay, so daemon is the one who is receiving your actions. Like for example, if you're talking about Jenkins, so you have your Jenkins master. So daemon is like the Jenkins master, which is receiving all your requests. Okay, and this master will execute the request that you have sent. For example, you are running Docker build. So daemon will try to take this action. Okay, it will understand, oh, okay, this is the Docker file, this is the Docker build command that the user has given me. Now I have to perform Docker build and create an image. Okay, similarly, let's say you're submitting a Docker run command through the CLI to Docker daemon. Then it will understand, oh, okay, I have to run a container, so let me perform the container execution action. And every command that you use, whether it's Docker pull, Docker push, uh, anything that you will try to do with Docker, right? Whether you are trying to perform some system related actions to prune the images, all the actions are received by the Docker daemon. If you try to stop the Docker daemon on your laptop or any of your production servers are where, you will understand that, okay, if the Docker daemon is run, if is down, and if you are using Docker as your container runtime, then you will realize, oh, okay, so the containers are not running because the daemon is wrong, daemon is down, right? So this is how you explain the different components of Docker. So basically tell them that you have a client, you have your Docker daemon, and then you have your Docker registry, which is running again as a container, or depends on how you want to. Some people might want to have a external Docker registry, that is very personal to your organization, or you want to create your own Docker registry. Then you can create one Docker container. Registry is again a container, so that can essentially be used to push your images or pull your images. Then what is the difference between Docker copy and Docker add? So this is a fairly simple question, don't get confused here. So copy and add, like Docker add command can copy the files, or files or whatever you are trying to do, from a specific URL. Let's say you want to get a log file from some AWS S3 storage, or you want to get some Java related file, or any text file from GitHub as a raw file. Okay, so in such cases you can use Docker add. Okay, so the simple example is, let's say you want to retrieve the log file from S3 bucket, or you want to download a specific package from internet using wget or curl. So in such cases you can use the Docker add command. Once you give it the URL, it will try to download. Whereas Docker copy is basically used to copy the files from your file system. Let's say you want to copy the source code from your file system, from your laptop, from your EC2 instance into the container. In such cases, you will use the Docker copy command. So fairly different. There is no similarity between both of them. People get confused when they try to explain to the interviewer. Just be clear. Then what is the difference between CMD and entry point? Many people also ask the same question in our comment section. And I have explained this with a real-time example. Watch our day 27, where I showed you why command and entry point are used, and how to use the combination of entry point and command as well. I showed you, right? So you can also watch the GitHub repository. I'll share you the GitHub repository link for Docker Zero to Hero, where I explained you exactly how to use the combination of command and entry point. Now coming to the question, what is the difference between CMD and entry point in Docker? So CMD is basically, let's say you want to pass some arguments to the container, and these arguments can be overridden. I'll give a very basic example. Let's say you want to run a Python related application. Now for this Python related application, let's say it's a calculator function. Okay, so for this calculator function, you want to read the arguments from the user, or you want to read some kind of command line arguments, or any uh, things from your user. Let's say for the calculator, I want to perform addition functionality, and I want to get the output of 2 plus 3. So in such cases, what you can do is, for the entry point, you can provide the name of the function, and because the other parameters are configurable, like user can provide addition, user can provide subtraction, multiplication, or division. So in such cases, how you do is, the parameter that should not be overridden, pass it as an entry point, or the function, or the executable, which should not be overwritten should always be passed as an entry point, and the parameters that can be overridden, or any fields that can be configured, that should be passed using the CMD. So there can be a question like, okay, should I mandatorily use both command and entry point? No, you can either use one of them or you can use combination of both of them. So here, that's why I explained CLI arguments using Docker run command will override the argument specified using the command instruction. If you are using CMD, then whatever you are putting in your Docker file as your first command that you are running inside the container can be overridden. Whereas if you are using an entry point, so in these cases, your commands or your arguments will not be overridden by default. Okay, so this is the difference between CMD and entry point. So again, the example, let's say you want to run any Python application, or you want to run any Django application where you have arguments like Python manage.py followed by the URL, the host port, and all of these details, right? So what you can do is Python and manage.py, you can put it in the entry point, whereas the other details like what is your host URL or what is the port, you can pass all of those information in the CMD, so that user can, okay, user can say that, no, no, I don't want to run it by default on the 8000 port. I want to run it on 9000 port. So in such cases, if you pass those things as part of your command line arguments, then it will be overwritten in the CMD. Question number 7. What are the networking types in Docker and what is the default? So again, we explained these things. I mean, in the previous classes, I explained these things in very detail. I will share the GitHub repository link as well. But if you still do not understand what are the different networking types in Docker, the default networking type is bridge networking. Okay, but you can modify this network. Either you can go with bridge network, overlay network, host network, and MAC VLAN network. So one of the important questions that interviewer will ask you is, once they ask you what are the different networking types in Docker, they will ask you what is the difference between these networking types. So on a very high level, if I have to explain you, in the GitHub link, I have provided very detailed explanation, but for the specific video, if I have to explain you, bridge network is the default network. And what happens with the bridge network is there is a virtual Ethernet or v8 or Docker 0 network that is created, using which a container can access your host network. For example, if your user tries to access the application through your host to the application that is inside the container. So if you are creating the bridge network, what he will do is he will try to firstly access your host. From there, using this virtual Ethernet or Docker 0 network, he will try to access the application that is inside your container when you do the port mapping. So this is the default methodology. Whereas you can also do the host network, where using the host network, you will bind your host network with the container network. So container will be part of your host network itself. So users can directly access the applications inside the container using the host network. There is no virtual Ethernet or there is no Docker 0 here in this case. So if you see this example here, so this is the virtual Ethernet. Okay, so container, virtual Ethernet, Docker 0, and this is your host network. This is about the bridge network, and if the host network, you don't have all of this mechanism. Coming to overlay network, overlay is slightly complicated when you have multiple hosts or when you're dealing with Docker Swarm or Kubernetes, these kind of things. Overlay network will come into picture, where you can connect. Overlay is basically a networking type where you can connect multiple hosts, or you can create any overlay type of networking. So it's like a tunnel type of networking. So Mac VLAN network, again, it's again, for somebody who is trying to understand the containers, you when you want to explain to the interviewers, you can say that this mode allows, I mean, the Mac VLAN network allows a container to appear on the network as a physical host rather than a container. So what happens is, whenever you are configuring this Mac VLAN network, your container will actually appear as a physical host rather than a container, right? So this kind of networkings should only be used in very special cases, like, you have to sit down and understand, do you require this kind of networkings like the host network or Mac VLAN network or even the overlay networks? Because when you are doing these kind of overlay networks or Mac VLAN networks, you're only complicating, because with Docker you shouldn't by default go with this kind of networkings unless you have any special requirements. Now, the next question is, can you explain how to isolate networking between the containers? So this question can be a follow-up to your previous question, where interviewer will try to understand. Let's say there is a container called payments, and this container payments should be completely isolated. Like there should not be any common path. If you are talking about the bridge network, like I showed you, what happens is all the containers use the Docker Zero network. By default, if you try to create containers on your laptop or on your EC2 instance, what happens is the default network is each virtual Ethernet, that is Docker Zero. So every container use this Docker Zero network to connect to your host. So whether it's a login container, logout container, or payments container. So if you see the example here, every container uses this vEth network. Using this vEth Docker Zero network, they will try to connect to the host. But what I want is, I want to separate these things. Like let's say there is a let's assume that this is a login container and this is a finance container or payments related container. I don't want both of them to use Docker Zero, because if both of them are using Docker Zero, there is no networking isolation. So for some reason, if the login application or login container is compromised, there is a security attack on this login container. So my finance or the payments container should not be compromised. So in such cases, what I can do is I can do a networking isolation. So how do you do networking isolation? Is if you see the picture here, what I have done, this is my web container or this is my login container, which is using the default Docker Zero network. But if you look at the right side, this is not using Docker Zero network, but it is using my bridge. So the answer to this question is you can create your own bridge networkings. So using your own bridge networkings, like you can assign your own network to a secure container. You can say that there is create a new networking in Docker using the Docker network create secure network. Okay, so now what you can do is whenever you are running the container using Docker run command, you can say hyphen hyphen network is equals to secure network, and you can like when you do this, the container will come up with the secure network that you have created. By default, Docker will create a CIDR block or subnet for you. And now whenever the container is trying to access the host, or whenever it is trying to access EC2 instance, it will access the, or it will connect to the EC2 instance through that secure network. So there is a network proper isolation. This kind of isolation can be seen in virtual machines, because when you create virtual machines, each virtual machine has their own operating system, they have their own kernel, and they have their own Ethernet, right? So every virtual machine talks to your host with a separate network. So to achieve these kind of things in Docker containers, what you can do is you can create your own bridge networks. Okay. I also showed you this with example in the last class. So you can watch day 28. I'll share the video links as well. So in day 28, I created a live example and I showed you how to do this, how to achieve this network segregation. I use the ping command to also show you that one container is not able to talk to the another container. Then what is a multi-stage build in Docker? So these are some of the concepts that will understand, I mean, that will make interviewer understand what is your level of experience or on Docker in practical way, whether you're using it in your organization or you are only doing some practicals by your own. Because multi-stage Docker builds, whenever you are doing some practice on your own on your personal laptop, you will not use this multi-stage Docker build. But when the things like Docker image size, when the things like Docker the ecosystem is very important to you and your organization, you will try to think in building lightweight containers, right? The concept of container itself is to keep it lightweight. Now to achieve these things, what you need to do is you have to use concepts like multi-stage build. In day 26, I showed you how to reduce Docker image size by 800%, right? So if you watch that video, I'll share the link in the description. We reduced the Docker image size by 800%. So we used a simple Golang application. We used the default Docker image, that was the Ubuntu base image, and we ran that application. We saw that the image size was 800 MB, and then I used a different Docker image in the multi-stage build. And what I did is I copied the Docker binary, or sorry, the application binary from stage one to the final stage, which is a simple, very basic image. It does not have any Ubuntu or it does not have any runtime dependencies. It was a simple distroless image. So with that, what happened is I just copied the executable from stage one to final stage, and the final stage or the image that is running will only be the final stage one, which is only 1 MB. So from 800 MB, the Docker image size went to 800, from 800 MB to 1 MB. So the definition is multi-stage build allows you to build your Docker container in multiple stages, allowing you to copy artifacts from one stage to the another stage. So you can explain using a very practical example. Let's say you have a multi-tier application where you have front end, back end database, and the final image will be just one jar file or ER file. Let's assume. So for front end, you will have dependencies with React or Node or Angular or something. So you will copy all the dependencies. You will, basically using pip command or basically using the apt command, you will install all of those things. Then when you are trying to build things related to your backend, let's say it's a Java application, again you will install all the dependencies, like you will install JDK, you will install JRE, all of those things, right? And finally, let's say it also has some information like connectors with respect to the DB, so you'll also install those connectors. And when you try to build this image and see, the image size will go over 1 GB because you have lot of dependencies that you have installed on this image. But the final executable just requires JRE, right? It just requires a Java runtime, or let's say it requires Java runtime plus React runtime. Okay, just for example, I'm telling you it doesn't require, but let's assume that it requires two different runtimes. But all the dependencies that you have installed was only required using the build phase. Once the application is built, all these dependencies were not required. So what you can simply do is you can use multi-stage build, and in the last stage, you can simply copy the binaries or the executables that you have created and just take them into the final stage. And in the final stage, just install Java runtime, not all the packages. So you'll see that the image size from 1 GB will come down to 200 MB or 300 MB. So this is the concept and advantage of multi-stage builds. Question number 10. What are distroless images in Docker? So this concept is fairly new. Like you can consider it has gained the popularity over last 2 to 3 years or 3 to 4 years. So the concept of distress images is, once people started using the containers, what we have noticed is containers are also exposed to some security vulnerabilities. If you're using virtual machines, the virtual machines will have lot of packages, it will have the complete operating system. So it is understandable that, oh okay, whenever there is some security threat identified on Ubuntu, there is some security threat identified on your base operating system. So your virtual machine was also getting exposed to these issues. So you are fixing it. But after moving to containers, the main goal was applications should not be exposed to these kind of issues, because containers are meant to be lightweight applications and it should not have a lot of system dependencies, right? But what people were doing is, like in the previous example, they were installing all the required and not required packages into the container image. Let's say for the same example, if it is a Java application that has React and some DB related stuff, people tend to install all of these packages. And again, you are running into the same problems with virtual machines, that when you have a lot of packages, there is more scope of exposing yourself to vulnerabilities. Let's say you have a MySQL package, so somebody identifies a MySQL vulnerability. So again, your container is exposed to it. You have to go back and inside your Docker image, you have to update the MySQL version, and then you have to run the container again. So to solve this problem, people said that, oh okay, for containers, the idea should be just should have the runtime, right? If it is a Java application, it should have just Java runtime. If it is a Python application, it should have Python runtime. And if it's a Go application, you don't even need runtime. So why we should install all of these packages? So let's try to shrink down the image size. So that's where the Docker destroless images have taken birth. So the Docker destroless images are very, very minimalistic images. Okay, so similar to other images, let's say there is a Ubuntu image. If you try to compare it with the basic distroless images like Scratch, so Scratch is a distroless image. So if you just do from scratch colon latest, you'll see that it will be hardly less than 1 MB. Okay, whereas if you do Docker pull Ubuntu, you will see that the image size is close to 100 MB. Whereas if you do Docker pull Scratch, the image size is only 1 MB. The difference is that Scratch is a distroless image, and the what this people at Docker has identified, or what the people at Google who are basically started this concept of distroless images, they have identified is we can remove a lot of things from the base Docker images. Like the popular images that people were using till then were Python image, Ubuntu image. If it's a Java application, the OpenJDK image. So these were the base images that people were using. Now in the DistroLess images, we removed all of the things. Like if you go to a DistroLess image and see, there will not be even some basic folders or basic commands. Like you will not have apt, you will not have if it like you'll not have any system package managers like yum or apt or all of these things. So they also consume a lot of space and lot of resources. So everything is removed. Even if you try to execute basic commands like curl or wget or ping, you will not have those things in the scratch image. So scratch, I mean DistroLess image. So DistroLess images are very lightweight minimalistic Docker images that should be used so that the security your application will be less exposed to security implications, or with respect to security threats, your application is less exposed. So these are the 10 questions. Now I will move to some real time challenges with Docker. Every interviewer, like if you are like doing your final round of your interviewers will try to understand what are the real time challenges that you have faced, whether it can be with Jenkins, whether it can be with Kubernetes. So today we are learning about Docker. So what are some of the real time challenges that you faced with Docker? So look at the answer very clearly, because I have provided the details that you can directly communicate the same things to your interviewer as well, because these are some real-time Docker challenges. The first challenge is the Docker daemon itself. Like if you go back to the example here that I explained, if you look at the Docker daemon, what is it doing? It is a single process, right? So this is heart of Docker, and this is a single process that is taking all the instructions, right? Let's say if this Docker daemon is down, you try to do Docker build, Docker bull, Docker run, or even if your containers are trying to run, or the running containers, they will face issues because the Docker daemon, which is heart of your Docker, is down. So this is a single point of failure in Docker, and this is a very major challenge. Like let's say in your production, all of a sudden your Docker daemon process is down, right? So that's a very big issue, because this is a single point of failure for Docker. So this is one of the major challenge, and tools like Builda, Podman address this challenge. Even if your interviewer asks you this question, do you know any modern day solutions that address this problem? You can say that, yeah, Podman is one such thing that does not have a daemon, that does not have a single point of failure. And even I am trying to learn Podman. If you don't know Podman, you can say I'm trying to learn with Podman, and I came to know that Podman can also run the same Docker instructions. Like Podman is a tool which address the Docker problem, but it can take your Docker commands as is. Like you can say Podman build, Podman run, all of the same instructions that you are doing with Docker. Now, I'm not going to the details of Podman, because I'm only explaining you the real-time challenges of Docker. Then the next question is, sorry, the next one that you can say about the issues with Docker is the daemon. Again, it runs as a root user. Like if you have identified any time, whenever you try to perform any Docker related actions, right? There is these instructions are issued by the Docker daemon, and if you do ps-ef, or if you try to see with which user is this daemon process running, you will see that it is running as a root user. Now, any application or any process that is running as a root user, it is tend to, or it is exposed to security implications, because for some reason, if this Docker daemon is compromised, because it is running as a root user, the user or the hacker who has hacked this Docker daemon, or who has got hold of your container, let's say the hacker has got hold of one container, and if your container is not configured well, if it is running as a root user, or if he has got hold of your Docker daemon, he gets access to your entire host, or he gets access to your entire cluster. So that is one reason or one problem with the Docker daemon, because it is running as a root user. Again, this problem is solved by Podman. It doesn't run as a root user. Then there is resource constraints. This is problem with the containers itself, not specifically with respect to Docker. That if you are not configuring the resources well, then if you're running 10 different containers on a single host, if one container is leaking a lot of memory, or it is using a lot of memory, then the other containers which actually require the resources will not get the resources, because one container is using 10 GB, one container, for some problem with this container, it keeps on using more and more resources. It will have impact on the other containers. So you have to configure the resources very well for your containers. If not, the other containers will be impacted. So these are some practical problems with Docker. So everybody should, everybody should be able to answer these questions in your interview. What steps would you take to secure containers? So this is again very, very important, because right from day 24 to day 28, I always told you that the security with respect to containers is very important. When you move from virtual machines to containers, one of the major challenge is virtual machines are not as secure as your, sorry, containers are not as secure as your virtual machines, because virtual machines have a proper networking isolation. One virtual machine and another virtual machine, they have their own operating systems. They are full blown applications plus operating system. So there is very less chance of one virtual container or one application in the virtual machine impacting the other applications in a different virtual machine. Like, there are very less chances. If you configure proper VPC and all the things, then there are very less chances. Whereas with containers, if you don't consider the security well, then all the applications or all the containers will be compromised. Whether it's your containers, whether it's your team's containers, other project related containers, they will be compromised. So there are some things that you have to take care. The first thing that I would say is use distroless images. So if your organization is not using distroless images, you can put forward the idea of using distroless images, because like I told you, they will not have even minimum required packages. Like, they will not have package managers, they will not have some basic modules like curl, wget, or any other things. They are very, very lightweight in nature. They are just like 1 MB, 10 MB, 15 MB, that's it. So with that, the advantage would be, if you're using a scratch distroless image, there is a very less chance of your container getting exposed to the external vulnerabilities, not with respect to your application. Like, if your application has vulnerabilities, then distroless image cannot do anything, but you will not have vulnerabilities with respect to the container image, right? So this is one thing that you have to take into consideration. Second thing is, you have to ensure that the networking is properly configured. For example, like I told you, there is a finance or payment related application, and then there is a login related application. So if this finance related application has to be secure, it should not have any communication with login application, then create a different bridge network for it. Okay. And this bridge network should, it should create a different path for the container to talk to the host, like the example that I showed you, right? So this way, when you properly configure networking, it will allow the containers to be secure. Finally, there are some very good utilities like sync to scan your container images. So whenever you create container images, whether it's in your Jenkins pipeline or whether you create manually, always try to use these utilities like sync to ensure that your images does not have any vulnerabilities. Okay. So you can simply use the docker sync command, or you can even use the sync directly to scan the container images before you push them to production or before you push them to your staging environments. So these are some of the security related aspects that you can consider for your containers. So these are the 12 questions that I have for today. Let me know in the comment section how many questions were you able to answer. Be honest. And if if you want me to make video on any of these topics in detail, if I have not covered from day 24 to 28, again, let me know in the comment section. I'll definitely consider. So if you like the video, click on the like button. If you feel that there is any feedback that you want to share with me, do not hesitate to put that in the comment section. And finally, please share this video with your friends and your colleagues. Thank you so much for watching the video today. I'll see you in the next video. Take care, everyone.